We shall. Good. Excellent. Hello, my name is Scott Allen, and most speakers will get on stage and say, "Hey, I'm very happy to be here," but I am genuinely happy to be here. You might not know just how happy I am to be anywhere right now. um, yeah, I haven't done a conference for over a year. I mean, the last real public speaking I did was at NDC Oslo 2018. So I'm very enthusiastic to be here, and I hope I remember to do all the things that speakers are supposed to do. We'll find out. The talk today is on advanced Azure App Services, and this talk, when I put it together, I do the same thing that I do for most of my technical talks, which is this is the talk I wish someone had done to me or for me after I had been working with Azure App Services for a little bit, and it would have answered all my questions and taken away a lot of the mystery, and everything would have been really good moving forward after that. So that's what I'm trying to do with this talk. And it does assume that you've probably worked with Azure a little bit. Maybe you know a little bit about App Services already, because I'd really like to dig into some of the finer details. But if you have never worked with Azure App Services, just the name to me, even when I got started with Azure, was like, what is an app service? It's such a amorphous, just technical term. Like app service is an app, is it a service? Don't know. But just to simplify it, in case you haven't worked with it, if you have an application, doesn't matter how you wrote that application, if it wants to receive HTTP messages over HTTP or HTTPS, App Services can host your application. And it doesn't matter if it's written in Python or Java or Node.js or assembly language. If you can execute your code on x86 or x64 based architecture, you can find a way to host it inside of Azure App Services. And then what would be the point of taking something and putting it into App Services? Well, the point would be that App Services is a platform. So it's not like you go out and provision a virtual machine and you have to worry about what operating system do I have to install? Do I have to configure IIS? Do I have to manage patches? No, it's not infrastructure as a service. It's a platform. So I go to Azure and say, please give me an app service. And later, when I'm ready, I will deploy my application or my web API into your platform, and you'll take care of everything. You'll manage the patches and the security and load balancing and all sorts of magic. So on the scale of infrastructure as a service to software as a service, App Services is definitely a platform offering from Azure, but that also means that App Services is an abstraction, and that's where things get a little bit tricky, because when you're trying to host your web application, and particularly when you're trying to figure out how is it going to perform, or something just went wrong, how do I debug this thing, what are the diagnostic steps I can take, that's when sometimes the abstraction can get in the way, right? As developers, we're very used to creating abstractions and writing methods that hide complexity, and App Services is the same way. In an ideal world, you would just say, dear App Services, here's my code. Now you take it, you run it, you send messages to it that are coming from over the internet, and you tell me when something goes wrong, and then I'll have to figure out what to do from there. So this talk is really about digging into the abstraction, because if anything, I feel like App Services is getting more abstracted as we go forward. So just as an example, if you go into the Azure portal, this is how you used to create an app service in Azure, or this is how you used to create an app service plan, and notice it's very specific. If you take this plan that cost at that time, and this is old, $75 a month, US dollars, you'd get one core and 1.75 gigabytes of RAM. And these days, the portal looks a little bit different. We don't even talk about CPUs anymore. We talk about 100 total ACUs, or an ACU is an Azure Compute Unit. So that kind of leaves everyone wondering, well, I have this application that runs on a four-core server here in the office. What do I put it into in Azure? Um, well, I can tell you generally the first digit there will indicate how many processors are in this particular offering. So 100 total ACU is a one core machine, but not all processors are equal. And that's kind of why they moved away from telling you how many cores there are to just telling you how many computing units there are. Because if you go into some of these premium plans, you don't get just any old Intel processor. You get one of the newer fancy Intel Xeon processors that has, I don't know, more transistors, more cache, and probably a faster clock cycle. So, there's a offering in there that's 210 total ACUs, because it's got that 5% edge over the other CPUs that are out there. So things like that are things that are I'm trying to figure out to peer behind the abstraction and take terminology that Azure provides, like these different offerings are is what Azure would call a stock keeping unit, S1, P1, V2, P2, V2. It's like they're offering products on the shelf of a store when they offer these different pricing plans for your app services. So hopefully you're going to find this interesting, and I'll just go ahead and lay out the agenda so you can figure out if you want to stick around or not. But what I'd like to do is get behind the app services abstraction and first understand some of the physical characteristics of app services, like how would you actually make this tangible? If I put an application into Azure App Services, like what is the actual hardware that it runs on? Can I reach out and touch it? Probably not. Everything's virtual, right? But we'll dig into that a little bit. We'll talk about the logical architecture of how app services works and what the different components are to make things work. I want to give you some performance tips for Azure App Services and talk about how you do some diagnostics. But I mean, there's a lot of things that I'm not going to cover. So there's a lot of things that are just covered so well on Channel 9 and Pluralsight and YouTube and places like that. So I'm not going to go into those demos that you can find every day. I'd kind of like to think that I'm presenting something a little bit different and a little bit unique, and just some of the experiences that I've had that, again, I wish people had told me about. So those are the different sections we need to work through. Let's look behind the physical curtain. So if I go out and create an app service in Azure, I kind of like to think sometimes about what is actually physically happening. So you all know that Azure has all these data centers spread out around the world. In fact, Norway West and Norway East are two data centers that are in the planning phase. So you'll have physical Azure servers and Azure buildings here on inside the country here sometime in the future. I don't know what the dates are for those, but so there's a lot of resources in Azure. Let me rephrase that. Most Azure resources are resources that you have to place into a specific data center, into a specific region. And so app services, Azure SQL, those are resources that I have to say, I want this in East US. I might put it there because I live near the East US data center, so it's close to me, and therefore the latency should be low. Whereas you might create an app service and put it in West Europe or ultimately Norway East one day, because I think that's supposed to be here around Oslo somewhere. And yes, but what actually happens? Here's what I think is interesting. I like to place myself into the role of someone who is actually managing one of these data centers. So imagine you are managing one of these data centers, and Microsoft comes to you, someone at Microsoft, and says, you need to build this data center, and what you have here is nice, but you need to scale it out and expand it to support 5,000 more customers by next year. And you say, oh, wow. So the one thing you don't do is just go to the Dell.com webpage and order 500 servers and 1,000 power supplies and so many feet of cable and just hope it all arrives on the right truck and put it together. No, there's well-defined blueprints and processes that Azure has to scale these things out and to build them. And typically, every resource type inside of Azure has an associated what they call scale unit, and you'll sometimes hear it referred to as a stamp. And the way I like to think of it is I like to think of it as a blueprint or like a C# class definition. So what happens when we need to make another object? Well, we instantiate the class and we stamp out new objects. Azure does the same thing. So let's say you need to support more capacity for more app services. Well, they take the app service class definition, the blueprint, and they stamp out another instance of app services capacity. So what is a stamp? Like what is inside one of these scale units, which, by the way, this is just pointing out inside of each data center, so West US, UK West, and so forth, there's one or more scale units that are sort of controlled by a geomaster that knows where all the different scale units are. So when you talk to Azure Resource Manager, which you haven't used it, but pretty much anything you create inside of Azure has to go through Azure Resource Manager somehow. It doesn't matter if you're using the portal or PowerShell or Azure CLI. Something has to tell Azure Resource Manager, please create a new app service in West US. So ARM would talk to GeoMaster, which would talk to one of these scale units, so it'll figure out which one is, has some capacity left, and that's what happens. But let's actually break down what is inside of a scale unit. So imagine a scale unit is something that includes potentially thousands of servers, like thousands of real physical servers that are sitting inside of this data center. What are the different roles that those servers take on? Well, some amount of this computing power is dedicated to creating a network appliance, which we would call the front-end load balancer. So when an HTTP request arrives for your service, your application that's hosted in an app service, it never goes directly into your app service. It first has to come through the front-end load balancer that's provided by Azure. And that front-end load balancer actually does SSL termination. So it decrypts everything right there, and then it will forward the request to the appropriate other piece of hardware that is inside of that stamp that actually is running your code. So there's some other physical server ultimately in there that has a virtual machine that's running your code, and the front-end load balancer knows how to direct that request to you. And for people that are terrified that this thing does SSL termination, we'll talk about that here in just a bit. But there's some other pieces of infrastructure in every stamp that gets stamped out. So there's some amount of computing power and storage that's dedicated to storing your application settings, let's say. So yes, Azure App Services does rely on SQL Server behind the scenes, and it relies on other computers that are what they call publishers, which provide like the FTP and the FTPS endpoints for people that like to deploy in that fashion. But then most of this that we're looking at, really, all these white blocks are just what they call the web workers. So these are the servers that ultimately, when you run your app service, you're going to be running code on one of those web workers that are just sitting around waiting for something to work on. So you could have your app services deployed here, and I show it having 6 blocks because maybe your app services or your web service is much more popular than my app service, which only needs one-third of the computing power that you need. But we're all in there together. We're all inside that same stamp. Right, we're all, and again, if the idea of being in a shared environment terrifies you, we'll talk about that in just a bit. But in a stamp that would be underutilized, like the rest of these blocks are just ready to go. They're ready for you to scale up or ready for me to scale up. They're just warmed up VMs that are ready to take your code and ready to start receiving requests and ready to start executing. So this is important just when you're trying to for some specific scenarios that come up inside of Azure. It's just important to know about this architecture. And you might be saying, well, do I know what stamp I'm on, or can I control what stamp I get deployed into? I don't want to be deployed with this guy's Azure application service or something like that. And the answer is no. You provision an app service, it's going to pick it somewhere. So my site, odecode.com, runs an Azure App Services, and if I do an NS lookup, I'll get back an IP address that, if I look up that IP address, it clearly would point to Microsoft owns that IP address, so it's pointing to something inside of Azure. In fact, that IP address should point to one of those front-end load balancers that is part of a stamp somewhere in the East US data center. And if I also do an NS lookup on odecode.azurewebsites.net, because odecode.com is my custom domain that I map to that IP address, but Azure provides this domain to me for free. That maps to the same address, 168.624.8183, but notice one of these aliases is actually Azure Websites.windows.net. Notice the prefix here, WAS, so that's Windows Azure Websites. And I used to think, oh gosh, I'm on one of the VIP stamps. Like someone inside of Azure recognized, hey, it's Ode to Code. Let's put them on the very important person stamp. But no, that's not true at all. That was just me fantasizing. VIP would actually just be virtual IP, because in fact, because that same IP is shared by everyone else that is inside that same stamp. So if you go to the website first of all, if you try to go directly to that IP address, that's basically the front-end load balancer saying, sorry, I don't know where to send this HTTP message, because if there's no host in the incoming HTTP headers, the load balancer has to give up. It's like, I've got all these sites to manage. You're not giving me enough information to find the one that you're trying to get to. So yes, I can respond to this IP address, but I don't know where to go. But if I take that IP address and plug it into a website like Find Your IP Neighbors, so this is the IP for my website, odecode.com. There's at least 1,100 other websites on that same stamp. And you can see some of them actually are .NET or SharePoint or Microsoft-oriented bloggers. So there's a number of us out there. But this doesn't even include people that might be fronted by some other service like Cloudflare or something like that, or people that don't have custom domains. And I'm not even sure how IP Neighbors works or how well it works. But if it can find 1,100 things, I'm sure there's at least 1,102 out there, if not a lot more. So I'm not special. I'm just one more. My website is just one more website that's on a whole big collection of websites. So that gives you a little bit of an idea behind the physical curtain, which I think is important to understand if you want to start doing troubleshooting, like you're trying to figure out what is the IP address and open firewall ports and things like that. You might think you might think you're opening a firewall port to just your website, but chances are you're opening a port to a virtual IP address that maps to thousands of sites, and some of them might be good and some of them might be bad. So logically, though, what is an app service? Just take a moment to describe this. So when you create an app service in Azure, you probably know this, but you have to create also what's known as an app service plan. And the important thing to understand is that when you create the app service plan, what you're really doing is you're selecting the characteristics of the virtual machine that's going to host your application. So in most cases, what you get is a dedicated VM. Yes, there's tiers like this free tier right here where you actually, that's the old school shared hosting. You're going to be on a virtual machine with other sites. So most people don't like that option. For one, you have to have a website that can run just using 60 minutes a day of computing power. Otherwise, you've exceeded your threshold for the day. So most of us are going to pick something that gives us a dedicated VM, like this one here that has 100 total ACUs, 1.75 gigabytes of memory. That's under the dev and test workloads. You can also go for production workloads. And then isolated is interesting because, again, if the thought that you're sharing a front-end load balancer that does SSL termination and sends off requests into a pool of workers that is co-mingling your customer stuff with a bunch of other people, if that thought terrifies you, that's when you go for one of those isolated plans, because the isolated plan essentially gives you your own stamp. Right? Everything is dedicated to you. So that means that you don't have to worry about, if you're building an application in an industry that's highly regulated, has all sorts of compliance rules, if you're working for like PCI compliance, chances are you're going to need the isolated environment that gives you dedicated resources and none of this multi-tenant stuff inside of the stamp. But it also means you're going to pay a lot more for your app service. But some of us have to do that. And let's see, that's just an example of one of the production tiers where that's going to be a 2 CPU virtual machine, but it's actually 210 ACUs because it's one of those newer D version 2 series VMs that's going to host my app service plan. And then the important thing to understand about an app service plan, you probably know this already, is first of all, whoops, gave it away. Every app service has to run on an app service plan because it's the app service plan that provisions that virtual hardware that you can execute on. But the important thing to understand is that you can place multiple app services on the same app service plan. So that's just like deploying 3 of your applications under IaaS on Windows Server. And this is what you want to do because and again, this might not be up to date, but for $40 a month, if we round it, you can have a 1-core, 1.75 gigabytes of memory virtual machine, which may be overkill for just one app service. And I have worked with development teams where I've gone into the portal and I've seen these microservice architectures where they've set up a development environment where every little service gets its own app service plan. So they'd be spending $120 in this case, $120 a month, when probably the test instances were small enough to all point them to the same app service plan and conserve some memory. Because then the nice thing about that is if you do have all 3 of those app services, so 3 different applications, all deployed to the same app service plan, you can scale them all together. And of course, app services gives you the ability to scale up and down, which is change the app service plan to add more resources. So this would be an example of scaling up from a basic 1 plan to a standard 2 plan, so doubling the amount of processing power, doubling the amount of memory. Also, standard has a number of additional features over the basic tier, like the ability to add deployment slots and so forth. And that's the thing to do if you have a stateful application. Sometimes with a stateful application, you get stuck with scaling up and down. That's the only way to do it, because the alternative is typically what you want to try to do when you need to scale out to support more customers, and that's scale out and in. So by default, when I create that B1 app service plan, I'll be running one instance of that virtual machine with my code, and that front-end load balancer will send every request to my application to that one machine. But if I'm busy enough, I could just go into Azure or tell it to auto-scale, and I could run 5 machines or 10 machines. Or I think, I want to say with the standard plan, I think you can go up to 20 instances. And then with the isolated plans, I think you can go to 100 instances. And that's a lot of computing power. If you need to go beyond that, there's some other tricks you can do, but we can talk about those later. Is this kind of what you came to hear, I hope? Anyone? Yes, good. At least a couple nods. That's good. So one important characteristic here then is that you need to decide how many app service plans you need for your applications and your services. And a lot of times that could be decided by what are the scaling characteristics. So if you have one really popular application, maybe you pull that out and put it on its own app service plan just so it can scale independently of those other applications and services that you have deployed into the cloud. So they could be entirely different plans from entirely different pricing tiers if you want. But this, we call that the density. How dense do you pack your applications onto your app service plans? How many of your services and applications can you put on a single machine before it, before it cripples it, basically? And those are things you just have to figure out through load testing and so forth, obviously. And just one thing to be aware of, in the standard tiers and above, you can create what's known as a deployment slot. I won't go into deployment slots a lot, but I think the standard tier supports up to 5 deployment slots. And deployment slots are nice because I can do zero downtime deployment. So if I have a new version of my application to push out, I don't have to immediately overwrite production. I can put it into a deployment slot, test out that deployment slot, make sure that the new code is happy inside of Azure, and when I'm happy with it, I can tell Azure to swap that deployment slot with the production slot, and all of a sudden that new code is executing inside of production, and it's warmed up, and it's ready to go. And that's nice, but just be aware that your deployment slot that you create, so if I create a staging slot, let's say, that by default is on the same app service plan as production. So if you want to create a deployment slot for load testing, obviously that is a problem because you might as well load test production, right? You're on the same machine. Create a different app service plan for your load testing. Also, a lot of people need to know what the outbound IP addresses will be. So if your app service is using, let's say in .NET Core, it's using HTTP client to make outgoing web service calls, and someone needs to open a firewall for that or what have you, how do you know what IP address it's coming from? Well, you just have to add 3 or 4 or 5 or 6 possible IP addresses. We're not going to give you just one for the app service, but those are all the IP addresses that traffic might appear to be coming from when your app service calls into the outside world. And again, you can change characteristics like that if you go with the isolated plan. You can have complete control with those isolated plans over your environment. And that's another reason why people will pay the extraordinary, well, I mean, it's more expensive than the standard plans. Those isolated plans are a lot more expensive. They'll pay that money to have more control, more security, avoid the multi-tenant architecture of the Azure stamps. And what's in this VM? So if an app service plan creates a VM, what does that VM look like? What's inside of it? Well, you probably know with app services, you can create a Windows-based app service, in which case, currently, what you would get is a virtual machine that has Windows Server 2016, has IIS installed, and the expectation is that you would run your application behind IIS. So most everything you would deploy to a Windows-based machine, whether it's ASP.NET Core or even Node.js, it'll run behind IIS. But you can also these days pick a Linux-based app service. And what can be really confusing in the Azure portal is that you get this drop-down list that basically says, and this comes before you make the choice between Windows or Linux, you get this drop-down list that basically says, what is your runtime stack? Do you want to run .NET Core 1 or 2 or 2.2? Do you want to run Java? Do you want to run Node.js? So you pick what is the optimal environment for your application. But some of these will only work on Windows, obviously. ASP.NET 4.7 uses .NET Framework 4.7, which will only ever run on Windows. So after you make that selection, you'll be running on Windows, and you'll get a Windows VM that has ASP.NET 4.7 installed. But some of these options, like ASP.NET Core 2.2, you can pick to run that under Windows, or you can pick it to run it under Linux. And essentially what happens in well, I'll come back to that. Hopefully this is making sense. So you can have a Windows-based app service, you can have a Linux-based app service, and in those cases where you just have something that's so extremely different that you don't want to work with any of those stacks, or you have some special things you want to install, which we'll talk about here in just a bit, you can just do a container-based app service. So you can come up with any custom Docker container that has whatever software you want installed. Let's say someone at your company wrote their own custom web server using C++ 10 years ago, and you feel very confident that you want to expose that on a public IP, then do that through a container, right? Build your own custom container image. You tell App Services basically where to grab it from, what container registry. It can be a private container registry. It could be a public container, and you're off and running. And then, but when I say that App Services, that you're working with a virtual machine, it's not the kind of virtual machine that you just RDP into, or that you use Secure Shell, then you go into and you just customize it from there. You kind of have to be careful about things. Yes, you can use Secure Shell to get into a Linux-based app service. This is an example here. You can also use something like apt list, and sorry for the slow font there, to see, what is this environment? What is installed on this machine? What do I have to work with? And you'll see all the usual culprits of, we have bash to work with, and we have all the standard libraries and so forth, and gzip and so forth and so on. And what if I want to customize that stuff? Well, that's also a good case for a custom container. This is what Windows would look like. Whoops, where did we just zoom to? There we go. You create a Windows-based app service and open up a console for it. You can look at the D drive and see, hey, there's 7 zips installed. And there's even things like some of the Visual Studio common components are installed on this machine. There's a program files x86. There's 2 different versions of Python. But what I want to talk about is when you look at this, you start to wonder, and again, that's Linux-based. You'll notice this Linux-based file system has a home directory. The Windows-based file system has a home directory. And you might look at this and you say, okay, I have my application, it's running on a VM. How does this file system work? What can I do with it? Can I store files on it? And the answer is absolutely. Azure App Services has this concept of persisted files. Persisted files are anything that lives in the home folder. So again, by default on Linux, that's /home. On Windows, by default, it's d:/home. Anything that you place into that folder is going to stick around because persisted files actually live inside of Azure storage. So app services are set up that when they load up that VM, they actually attach Azure storage as a network drive and mount it into the file system. So when you write something into D home, you're not just writing into some local SSD that's attached to the app service. You're writing into Azure storage, and it has all the redundancy and all those great things that means your data is pretty safe even if there's some natural catastrophe. But it also means, a lot of people have come to me and say, hey, all I want to do is deploy a WordPress site into Azure, and I don't want to do anything crazy to give users the ability to upload files. Well, it's perfectly fine for your WordPress site to just write to the file system, save images to the file system, and serve them from there. They're going to be persisted. And you might say, but what if I need to scale up and run 3 instances? So now I have basically 3 virtual machines running my WordPress site. It's okay, because they're all going to map the persisted file location to the same Azure storage location. So you write that file into your website on one machine, all 3 will see it right away. Making some sense? Thank you for sticking through to the end of the conference, by the way. I know this is just the type of stimulating content that will keep you awake and send you home with happy faces, right? So what happens if you want to customize this environment? What if I wanted to, let's say, install some additional components there on the Windows file system? Well, it's a problem because only the files in persisted files stick around, and persisted files does not include program files. It does not include bin under Linux. So anything I install, I have to be a little bit more careful about. For the Windows approach is to go into the Azure portal and do a search for extension on your app service, because you'll come to a thing that allows you to choose an extension that you want to install. And so, for example, let's say you want to install .NET Core 3.0, which currently is not included out of the box for an app service. It will be once it RTMs and everything is released and been tested for a while, but if you want to install it now, today, in preview, then you can go out and install the extension for .NET Core 3.0. And what that'll basically do is write an XML file into the app service so that Azure knows every time it brings this machine alive, it has to make sure that .NET Core 3 is installed. That's basically what's going to happen. That's how you customize a Windows-based app service. How do you customize a Linux? That's what Windows is becoming, right? Linux? A Linux-based desktop environment. Well, you create your own container, right? So you do it through a Docker file. So if you want some crazy web server installed, install it into your Docker image, put the Docker image into a registry, and load that thing into web app for containers. That's how you would do that. That's how you would customize it. How do you do deployment? Windows App Services, you can have a local Git, what's known as a local Git deployment. So essentially, if I want to deploy my application into a Windows-based app service, into a Windows-based VM, first I would create a Git repository on that Windows app service. That's very easy to do through the portal or through the command line. And that Git repository will live in the persisted files. So when I do a Git push into that app service, those files will be there and they will stick around. And but you can also pull code from Git, from any remote Git source. You can also do an FTP deployment, FTPS deployment, just copy stuff into that home persisted files folder any way you need to. And of course, Azure DevOps, which I think you've heard a lot about today, it has ways to push into Azure App Services. But behind the scenes, the important part here is that behind the scenes, Project Kadoo, which you've probably heard of, has all these hooks into the local Git repository, so it knows that you've just pushed code up, and it's going to jump into action and do what's known as a deployment, and just make sure it can do a build and run your tests and copy files into the right location so they can start executing behind, let's say, IIS. Same thing for a Linux app service. You can choose a local Git repository, remote Git repository, FTP or FTPS. Yes, the Windows app services actually have some features that aren't supported by Linux yet, so there's not complete feature parity there. And I didn't include all the sources here, but it's quite possible that the Windows app service also supports strange things like Dropbox and OneDrive and so forth that I don't think are on Linux yet. But not a lot of us, I think, don't do a Dropbox deployment. But and of course, if you're doing your own container, putting into app services, again, you have complete control over everything. So you can tell Azure App Services to monitor a specific container registry, a specific image. So if you ever update it in Docker Hub or Azure Container, the Azure Container Registry, App Services can say, oh, there's a new one, let's pull it and start it running. And that's a very easy deployment. What used to confuse me was, how does Azure App Services, if I push my code into it, how does it even know what to do? How does it know what to start? Like I can kind of understand ASP.NET, because ASP.NET has this long history of having a bin folder. And if I'm pushing up C# code to the server, I can understand, okay, it just does a compile, and all of a sudden there's a bin folder, and it's under IIS, so IIS will just load up a DLL from the bin folder. I can kind of see that, but it's still kind of a mystery to me. How does an application actually launch inside of Azure App Services? Well, it turns out that Project Kadoo actually uses a number of heuristics. So again, this is part of the abstraction magic of app services. It has a number of heuristics that just tries to guess, what is this person trying to do? If you push up code that includes a CS_proj file, Kadoo will say, this must be something with C#. So it's going to try to determine if it's old legacy C Sharp or C Sharp for .NET Core, right? And it's going to try to run the C Sharp. It's going to try to do an MS build on your project. But let's say you push up something that includes just a package.json. Then Kadoo will say, this must be a node project. Let's try to do an npm install, and let's actually look inside of package.json to see if there's a start script specified in there. So it's going to figure out you're using JavaScript. I'm going to try to figure out how to start your application. So it uses all these heuristics, and ultimately, what Kadoo will do, whether you're ASP.NET or ASP.NET Core or Node.js, it's going to write out a web.config file into your home folder, your home sites folder where your site is hosted. And if you want to change something, you can customize that web.config file that Project Kadoo writes out. And a good example of that actually would be for .NET Core. When I do a .NET Core from the CLI, if I do .NET Publish, it publishes my ASP.NET Core application and gives me a web.config because it assumes I might run under IIS, because historically that's what we've always done with Microsoft technology. And that web.config file gets deployed when you do a publish, and it will tell IIS inside of your app service what to do, which is essentially run the ASP.NET Core handler to pump requests through to your .NET Core code. What about for Linux? Again, there's many heuristics that are used. Let's say you set up a Git repository inside of your app service and you push up something that includes an application.py file. So in that case, Azure App Services will look at that and say, looks like Python. Let's try to figure out if it's Flask or Django and do the right thing, depending on what we're guessing. If it's Ruby, and how does it do this? I mean, it's very simple heuristic. So, and because it's all open source, even Azure App Services itself, open source, you can go in and you can see, okay, what is the startup logic for when something is detected as being Ruby? And how does it think it's Ruby? Well, it might just be looking for an RB file or a gem file, but this is how it starts your application. If it thinks you're pushing up a Ruby application, first it's going to see if, test for the existence of a gem file, and if not, I think the logic is if it's not, then just treat this as a static site and serve the files inside. Otherwise, if there's a gem file, then we have to restore dependencies, and we can use gem commands and Rails commands to start this application running. But you can completely customize the startup command. So you have some goofy, crazy application that was written by somebody in, let's say, Python, but they didn't follow any of the standard conventions, because all these heuristics are based around, what are the standard conventions for a Python application or a Node application or a Ruby application. If you don't follow those conventions, you can always set a custom startup command using the Azure CLI and tell Azure App Services exactly what to do. That was just so I remember that if you do write something in Python, you get the Junicorn web server, which would be what a lot of Python developers use for running their Python code. And of course, if you're writing something that's in a container, well, you specify the entry point in your Docker file. So when App Services spins up your container, it knows what to do. It's going to go to that entry point and do, in this case, initcontainer.shell, run that shell command. So you can start any process running that you want using your Docker file. So then the question might be, what if I have this crazy application that someone wrote in C++ that listens for HTTP connections on port 666 for whatever reason, but I want to host that in an Azure App Service and put it on a public IP? Well, you set your entry point so it'll launch whatever executable was produced when you compiled that C++ code, and then if you set the environment variable or the app service setting website's port to 666, that's the way of telling Azure App Services, okay, when I send requests to this particular container, I'll send them to port 666, and it'll hopefully give me back a response then. All right, moving along. Let me give you some quick performance tips. So now you've figured out how to deploy your application. You've figured out how to tell Azure how it gets started up. What are some common things that I do for performance tips? HTTP 2 might be the default now in Azure App Services when you create a new one. Anyone know for sure offhand? Yeah, I can't remember. I know I've had some app services around forever, and I had to go in and explicitly turn on HTTP version 2. And I'm not going to spend a lot of time on HTTP version 2. You can do the research and figure out how much nicer it is, and it's much more efficient at how it utilizes network resources like sockets and so forth. So make sure that it's turned on. You can do that in the Azure portal or with the Azure CLI. It's just going to be one of the settings that's available for your app service. Another thing I like to do is to make sure application request routing is turned off. So remember when we talked about the app service stamp, that big collection of resources that host your app services that has that front-end load balancer on it. By default, one of the things that front-end load balancer will do is it's really more of a proxy than it is just a load balancer. When it receives an HTTP request, it's going to send it to one of your virtual machines that's running your code. And when your virtual machine sends a response, it by default is going to add another HTTP header into the response that is the application request routing cookie. So it's just some unique identifier so that when that person, that client, returns to your app service with their browser, the front-end load balancer will look at that cookie and say, oh, you were running on instance number 2. So I'm going to make sure and take this request and send it back to the exact same instance. And that's very useful when you are writing stateful applications that are doing something like in-memory session, right? You want users coming back to the exact same RAM, exact same virtual machine. But these days, most of us are stateless. Unfortunately, the application request routing / affinity cookie is always on by default. So you probably just want to set it off because that'll give you an app service that's a little more resilient. You know, if you have two instances running and one of those goes down because it fails, or one of them has to be taken offline because it needs some security update or some patch, if you're not trying to route back to the same instance, you can just fail over real easy to the other instance, and the application looks like it's still up and running no matter what happens. Another performance tip I would have is to keep the app service always on. You know how IaaS, just by default, does this thing where your application is idle for 20 minutes. So just spin down the worker process, which is nice because that means you might be able to pack more services into the same machine and have them running. But it's not so good if you have a customer that comes back after something is idle and is waiting for that thing to spin up after their first request to it. So if you want to avoid cold starts, just go in and set always on to on, and you'll be set. Another tip is to keep dependencies close. So this is just one of those lessons I learned working with a big development team that was sort of turned loose on a microservice architecture. I was going through and trying to look through the Azure portal to figure out exactly what everyone had created. And it turned out that one developer had created an app service in East US that was talking to a database that was in the West US region, and it was sending messages to Central US to be processed by an Azure function that was in Australia or something. And I said, you know, this is all supposed to be part of a system, a single system. Why are we scattered all over the place? And we could have definitely improved latency if we put these things together. So there's a resource in Azure, don't know if you've ever heard of it, Azure Policy. Anyone ever use it? No. Oh, one. Yeah. Azure Policy, sometimes it's frustrating to work with, but basically you can define policy rules in JSON. And a lot of the Azure Policy is about compliance and about adhering to regulations. So it's very easy to write an Azure Policy that says all storage accounts must use encryption at rest. And you can enforce that policy, and if anyone ever creates an Azure storage account and doesn't have the always encrypted box selected, policy fires off an alert, and you go find that person and you admonish them. There's also an Azure policy rule that basically looks like this. It's very simple JSON, but it's basically a way of saying, find any resource that has a location that is different than its resource group's location. So assuming you deploy 3 different app services into the same resource group and set the resource group to, let's say, Norway East, but then you have a SQL database in that group that's in Australia, you know, that policy would catch that for you. Those things are hard to find when you're just poking around in the portal. So that's keeping dependencies close. Another one is to keep your assets close to customers. Once you get stuff inside of App Services, it's very easy to create an Azure CDN profile, so Content Delivery Network. And the Content Delivery Networks are are very cheap and can give you all sorts of features. So these content delivery networks work in different ways, but if I have a lot of static assets in my app services, I want to look at creating a content delivery network. And there's two ways to do it. One way is to put my static assets into blob storage and just point my CDN profile at blob storage and say, if someone requests image1.jpg, go to the storage account, find it, send it to the user. And the other way is to point the CDN profile at my app service. So it's a way of saying if someone requests from you image1.jpg and you don't already have it cached, come over here to my app service and grab it, but then keep it on your edge servers all around the world, keep it cached, and serve it to customers really quickly. So you can see the pricing is really quite cheap, and it talks about terabytes of data. Another thing to look at is Traffic Manager. Anyone using Traffic Manager? Traffic Manager is useful in a couple different scenarios. So Traffic Manager is basically a DNS-based load balancer. So what happens if I create my app service in East US, but then I have a large customer base in Australia? Obviously, there will be some natural latency in those requests. So it might be nice if I deployed my app services into both East US and Australia, and Europe, and everywhere my customers are. But then how do I give my customers just a single URL? That's where I can use Traffic Manager. And I can program Traffic Manager to say, look, I have these 3 deployments, one in Australia, one in Europe, one in East US. So when someone comes to ndcoslo.com, I want you to figure out what would be the best place to send them and return that IP address. So, is it the IP address for the stamp in Europe, or the IP address for the stamp, app service stamp that was created in the United States? And these are the different routing methods. So just real quick, you can do geographic routing, and you can say things like, all right, European customers stay in Europe, so all their data goes to a server in a data center that's also in Europe. Or you can do weighted, which is quite nice. Weighted is actually a nice way of doing like A/B deployments. So I can say, I have 2 app service deployments. I want you to send 90% of the traffic to that one, but 10% of the traffic over here. And the one over here with that 10%, that has some new features that we just want to evaluate before we make a change and send 100% of the traffic there. Those are the types of things you can do with Traffic Manager. But there's also recently introduced Azure Front Door Service. I have some horrible screenshots here. Let me, zoom in and make them even worse potentially. But Azure Front Door Service is a little more sophisticated. It does very similar things. You can think of it as a proxy that can sit in front of your app services. So again, let's take this scenario. I have customers in the US and Europe and Australia. I want my app services in each location so they're as close as possible to my customers. How do I route them between them? One answer is Traffic Manager. Another answer is Azure Front Door Service. Azure Front Door Service, though, is a lot more sophisticated. It does some of the same routing and health checks and so forth, but let me go to the next slide that kind of compares the two. Like, which one would you choose? So Traffic Manager is a DNS-based load balancer. So it relies on the DNS system, and that means it's cheap. It's also very easy to configure. It does do health monitoring. So if I tell it about my 3 app services on 3 different continents, it'll occasionally send off HTTPS requests to my 3 deployments and make sure it gets back a 200 response. And if it doesn't get back a 200, it assumes that particular deployment is bad or it's offline or something, and it can fail over to another app service. So this is also a good way to get geo redundancy. If my deployment in Australia suddenly sinks into the ocean, then at least we can fail over to the East US. Or well, let's say West US sinks into the ocean. I don't know. Let's not be so cataclysmic, shall we? Traffic Manager does offer different routing methods, but the downside of Traffic Manager is a slow failover because it is a DNS-based load balancer. So customer launches their web browser. They say, take me to ndcoslo.com. It returns an IP address. Then their browser caches that for 5 minutes, 10 minutes, half a day. Meanwhile, something has gone wrong on the network. We can no longer reach it. It takes a while for that to fail over. Front Door Service, completely different. It's a true proxy. So it's using a technology known as IP Anycast, which I had to do a little bit of research about because I wasn't keeping up with the lower level networking standards. But IP Anycast is kind of interesting. It uses the underlying infrastructure of TCP/IP network or IP networking to actually coordinate with routers to basically say, hey, dear router, I want to go to this IP address, and the networking infrastructure can say, oh, you go over there. Or you go over there because you live in the EU, so we're going to stick you over there. Or you go over here because that's the fastest route for you to reach. And so IP anycast can fail over instantly because it's working at the packet level, right? We don't have to wait for a DNS cache timeout. We can just start rerouting stuff right away. And because it's really a true proxy that's sitting between the client and your app service, wherever it's deployed, it can do intelligent caching. It can do what's called dynamic site acceleration, which is, I don't know, I think it's such a bizarre term, but that basically means it'll try to do things like compress content that comes back from your app service uncompressed, and all sorts of other network optimizations, some of which I don't understand at all. There's something called tcpip, I forget the term, something splitting. I don't know. It sounded very fancy, though. uh, you can do that research and figure it out. And Microsoft dog foods this thing to death. Like all the big services, like Xbox services and Bings and things like that, they all use front door service sitting in front of their servers to have these failovers and so forth. So Diagnostics, just a few quick words about diagnostics. All your app service deployments, you have the ability to turn on application logging and web server logging, and you can set retentions and quotas. And I'm not going to bore you with all that stuff because you can find dozens of tutorials on how to debug an app service. What I want to do is just call your attention to a few special things that I have found. So the first special thing is inside of the Azure portal, when you're looking at an app service, there will be this little tab that says diagnose and solve problems. And when I initially looked at this, I thought, this is going to be like Clippy used to be. I see you're trying to debug something. Can I help you with that? And then everything goes downhill from there. But it turns out this actually has some really cool, useful stuff in here. So let's say you have an app service that is just struggling, like it's having a performance problem. You can't figure out why. Is it CPU or are we paging memory in and out? Like what is it? Are we having, does it look like socket starvation problems, right? Are we having problems making TCP/IP connections to this app service? Is it trying to make outgoing calls and not connecting to our other third-party web services over TCP/IP? Like, what is the issue here? Some of those things, just to back up, yes, you might be able to find them out with logging, but I guarantee you, if you play around in this app service diagnostics a little bit, you'll find some pretty cool stuff. For example, I can drill into performance problems, and I can get really nice graphs here about, okay, here's my requests and errors for a particular site, and I can see that most things are green, which is good. So there's very few HTTP errors, server errors, which are colored in red, and they appear to be minimal. So that's pretty good, and there does appear to be some 404s in there. So if I'm worried about those, I can drill into them. But notice the tabs up here. I can get sort of the same level of granularity on CPU usage and memory usage. And then I can also, let's say, again, talking about TCP/IP connections, let's say there's some sort of weird starvation problem I'm facing. I can drill into those things and actually get it down into the weeds about what's going on. How many inbound connections do I have? How many outbound connections is my application trying to do? If there's just an extraordinary number of outbound connections compared to the last release, maybe someone has done sorry, trying to talk too fast now. If there's an extraordinary number of outbound connections that just seem to be hanging open, perhaps someone made a change in the way HTTP client factory was registered. Maybe go check that. Here's something else that's cool inside of there. Under App Service Diagnostic Tools and Resources, there's an Advanced Application Restart. So what happens if you determine that you need to trigger some new behavior in your app service, and the only thing to do is really just restart it because there's a problem? If you're running multiple instances and you click the big restart button that appears in the Azure portal, that just shuts everything down, so your application goes offline. The advanced application restart, which you can also trigger programmatically, can walk through each instance and shut it down, wait for it to come back up, get online. Okay, now we'll shut the next one down, shut the next one down, shut the next one down. So it's kind of a nice orderly progression of things there. And with that, we're getting very close to the end, except I have left a few minutes here for questions, if anyone has questions. If you do, you'll have to wave your hand madly so I can see it through the lights. Yes? Hmm.
where you can route traffic, like some percentage to different versions. And then there's this ARR infinity thing, which also says, okay, I'm routed to a specific thing.
Right.
Does they conflict somehow, or?
No. So the way to think of a deployment slot is think of it like a completely new app service, completely separate, but it's just hosted on the same app service plan. So the question was, does ARR affinity and deployment slots do they conflict anyhow? But deployment slots are like completely separate app services in a way. They're just on the same app service plan, and they have a different URL. Is the important part. So if I set up like a staging website for Ode to Code, I wouldn't go to odecode.com. I'd go to like staging.odecode.azurewebsites.net or something,
Okay,
if that
but
makes
like
sense.
like 10% of the users are they are really redirected to the new URL, so they get the.
Mm, yeah, well, I mean, that's something. So the question was if I want just 10% of my users to go to the staging slot, right? That's where I could get Azure Traffic Manager or Front Door Service involved. So I would tell them, here's one app service deployment. It's also just happens to be the one behind odecode.com. And here's another app service deployment, just so happens to be the app service that's behind staging.odecode.com. And just 10% of the users coming to odecode.com, just send them over to that staging IP or staging slot instead, if that makes sense. Yes, sir.
I kind of lost a step there. When you have some source code on GitHub and
Yes.
you want to, let's say it's a web application, and you want to deploy it to your app service, do you have any build steps that are necessary, or just publish it to your?
Oh yeah, I went through that part pretty quick. The question was if you have, let's say, source code deployed to GitHub,
Mm,
and you want it to just sort of automatically appear in app services when you do a push, yeah, you can configure app services to look at your GitHub repository and basically wait for a webhook to fire so that when you do a push into that repository on a specific branch, it'll just grab that code and do a build.
okay.
And you and again, there's heuristics used to generate a build script for you, but you can actually go in and tell Azure App Services, here's the build script I want to use. You know, you can give it a shell script and tell it exactly what to do. You know.
Very powerful.
Yeah, it's quite useful. So it's a quite useful platform. And I'm gonna hang around for questions, but I'll just leave you with this. There was a famous basketball coach in the United States. So you might not have heard of him because I know basketball, especially college basketball, might not be very popular outside the United States. But his name was Jimmy Valvano. He unfortunately passed away early, but he made a very motivational speech that I listened to many months ago. And he said, make sure you do three things in life every day. Make sure you learn something, make sure you laugh at something, and make sure you cry at something. So I hope you learned something, and tonight you can go out and laugh and cry. Thank you.